So welcome for my second installment for testing. So if you weren't here yesterday for my first installment, we kind of just did some high-level overview of what we meant by test-driven development and how we do testing from a FHIR perspective. And we introduced the Touchstone platform that I'm the senior architect and author of. And so we're going to keep going along those lines here. So, oops, let's see if I can actually... I hate it when it does this. Excuse me a minute. Okay, so my name is Richard Ettema, lead consultant with Aegis, FHIR certified implementer. I've been doing this for a long time. And as I said, I'm the senior architect lead developer for Touchstone. I'm also the author of the Aegis Wildfire public test server and client. So we have to have some way of testing the tests, so I have to, I build a test server and client to support that as well as using those that are out there. And just real quick, for those who weren't here yesterday, this is just a quick review here. Within the FHIR specification, starting with DSTU2, a framework for testing was developed and defined. And so essentially the URL that you see there, the testing.html, is where you can go to find out more information about that. But the framework itself defines what a test engine should do in terms of testing the FHIR specification. And it also defines the resource type of test script. And that test script is basically the way to define an executable test condition, test case, if you will. So a series of operations followed by asserts that evaluate how well it performed. So one of the aspects about testing that is really important is this concept of reliable and repeatable testing. And the workflow that we go through here typically follows this paradigm here. You run a test fails, you go back to the developer, they correct it, redeploy, and then you run the test again and hopefully test passes, everything's good. The question we have to ask ourselves is we need to be able to trust that that correction is being tested in the same way, because we don't want to introduce any anomalies in our testing as well and in the outcomes. So one of the ways that we ensure that is by known data. And known data means that we have known expected outcomes. In the hands-on exercises that I provide, I have a series of test scripts that I've already written, and one of those actually works through what I call the reliable, repeatable testing scenario, which is really two users, same data type of scenario. And I can demonstrate that if we have some time at the end here. Okay? But I do want to kind of get through the material. And again, if you have questions, that's okay. You can interrupt at any time. One of the aspects of testing is defining what your test criteria is. And from the FHIR testing perspective, those criteria or the rules are known as asserts. You execute an operation, and following that operation, you have one or more asserts. Well, you can do things like test simple values. Is this the patient that I expected? Is this the operational response, the HTTP response code that I expected? Did I get multiple matches when I expected only one? We can do conformance level testing. So we can invoke the FHIR validation engine and do conformance testing against known profiles from implementation guides. We want to test that elements are matching up to that validation. The required elements are present according to those rules. Is this the correct code value? Is it in the value set based on that validation? We can actually introspect it even more so and do specific data checking with additional asserts to make sure it follows the requirements of our use case as well. Conditionality within the FHIR specification is something that is a challenge in terms of testing. So it's important that we have a way to test conditionality of features. And we have a way of doing that in Touchstone that I can demonstrate as well, too. So let's concentrate on asserts here for a little bit. What can asserts do? Well, as I said, simple operations. So we can do conditional checking using various operators of equals, not equals, and so forth. And we allow for the use of expression language like XPath and JSONPath. So if you know the syntax, the format of your payload, so if I do a read operation and I pull back a patient resource in JSON format, I can use JSONPath expression languages to look into that resource and pull out data elements and validate them. If it's an XML, I can use XPath. So one thing that we do in Touchstone is we actually will take an XPath expression, and if it's JSON formatted, we'll do the translation for you as best we can. So it's not 100% guaranteed, but we'll try to translate between JSONPath and XPath regardless of what format you're in. But another mechanism which actually assists us in this fashion is the use of the FHIRPath expression language. So how many people know what FHIRPath is? Okay, so a couple of you. So it's basically another query expression language that has been expressly built for FHIR as a specification. It is a subset of the CQL type of language that's out there. So CQL is a superset of FHIRPath, if you will. Now, I'm not here to teach you FHIRPath, okay, but I am going to show you some examples of the use of FHIRPath and how we can put those into our asserts to kind of understand being able to do some more complex types of testing. So for conditionality and constraints and so forth, why do we want to support this? Well, obviously, FHIRPath as an expression language is a lot more functional. Thank you, Diego. FHIRPath is a lot more expressive than just what we can do simply with asserts, with basic simple operators. So as a full-blown expression language, it has additional functionality built into it that we can leverage. So we can do data conversion, we can do other types of things, functions like see if we're in a subset of something. FHIRPath itself as an expression language understands the FHIR structures. So it understands the data models of all the FHIR resources. But one of the interesting things about FHIRPath is that it treats every data value as a collection. Even though it might only be a single value, internally it's representing everything as a collection. We can get away with referencing a value as a singular piece of information in certain cases, but sometimes you have to kind of deal with the fact that you're dealing with a list or a collection of things. Another way that we can support complex asserts beyond FHIRPath is in the specification for testing of the test engine, there's this allowance for what we call rules or rule sets. And this is where you can, the FHIR test engine itself needs to implement appropriate support for an external scripting language like Groovy or Schematron or XSLT, that type of thing. And in Touchstone, that's what we do support. So we've built a rules engine that will support Groovy, Schematron, and XSLT. Let's take a look at an example of FHIRPath, though. Let's focus there for a minute. So let's have a condition here that we want to assert. So let's say, for instance, I've done a search operation in FHIR. So that's my operation that I want to test. Well, very simply, I may just simply want to confirm that I have at least one match back. You know, my bundle search set contains at least one entry. Okay? So let's keep it simple for right now. So if we take a look at XPath versus JSONPath and then how we would represent that in FHIRPath, it's going to look something like this. So in the upper left corner, we can see an assert defined within our test script where I have an operation of greater than, an XPath to the bundle total element, and I'm going to do a literal value comparison against 0. So I'm expecting bundle total to be greater than 0. So that's how you read that assert. They're ordered that way because the XML structure requires that we order them according to the schema of XML. If I do it in JSONPath, well, all I'm changing is just the path expression there. So I'm using a dot total. So in JSONPath, the dot represents the root element as opposed to an XML, you know, that root element specifically indicated. Well, that's how I might normally, yes?
You need to say which language are you using, or Touchstone will know which?
Well, yeah, so in Touchstone, as I mentioned, we'll actually allow both regardless of what syntax you're using for the payload. It will figure it out. So basically, Touchstone knows that the payload is in JSON or XML, but if it sees a path in XPath and I have a JSON format, it'll do that little conversion for you. I generally like to keep my path expression language matching my formats, just for readability purposes so I understand. So if I expect everything in JSON format, I'm going to use JSONPath.
And another question.
Mm-hmm.
Inside of the assert, you can tell what you want to tell the user because this is what you are searching for.
Yeah.
If it fails, what do you say to the developer?
We can see that in an example. So essentially what's going to happen here is there's a description element. I'm condensing down essentially just the key elements of the assert that we need to look at. But there's other elements that we can leverage, description and so forth. But Touchstone will generate an appropriate failure response based on the information you see here. So we can see what that looks like when I get to a little demo here. So how would I represent this as a FHIRPath expression? Well, I don't need to give operator, I don't need to give value, I just need to give expression because everything is now self-contained. Because FHIRPath is expressive enough where I can just give the conditional statement right here. There are some things you need to be aware of with FHIRPath though. Bundle.total by itself needs to be not converted, but at least you need to ensure that the value is represented as an integer because I want to do a comparison integer to integer, right? So remember, I'm dealing with a collection. So that total, it thinks it's a collection. By forcing it to integer, I'm telling it, force it to a single value that I know of is the correct data type. So those are some of the little caveats that you'll find with FHIRPath when you start working with it. And there's a whole FHIRPath specification site that you can go to take a look at that. Then I have greater than 0. You'll notice this is an escaped value here. Okay, and that's actually something in the test script when it's being executed via Touchstone, we found that you need to escape it appropriately in order for it to be interpreted correctly. So this is one way to do it where I'm actually accessing that bundle total element. Well, bundle total, if you look at the FHIR specification, is actually an optional element. So the search set bundle doesn't have to give total as a value. Generally, I do think that it should be there, but it's not a requirement. The cardinality is 0. So I could actually do an alternative logic here that is more guaranteed to work, which is bundle.entry with a count function. Because that's where all the results are going to be in the entry list of the bundle. And I can simply count them and then make sure I have at least 1 greater than 0. Okay? So that's just an example of comparison of just XPath, JSONPath, and FHIRPath as what you might do. Now, rules and rule sets is a different animal in terms of being able to do complex assertions. We allow the use of this, and it's part of the specification. It needs to be a little bit more fully documented within the spec. There are some aspects of it that is kind of loosely defined. So we're taking some Touchstone, and we've built it out according to what we feel is an appropriate implementation. We want to feed this back into the spec eventually at some point to make this more official. But the idea here is that if you build a rule, it's going to be either Groovy, XSLT, or Schematron. They are represented as separate files outside of the test script, and then within the test script, you make a reference to it, and then use it based on that reference. I can show you all this within Touchstone because we have display capabilities of showing everything that's uploaded in Touchstone. Rules are like one piece of logic. So think of that as like one assert. Well, we found that collecting rules together into a group is very advantageous. So I can reuse the same logic over and over again across many different operations, across many different tests. So we've come up with a construct called Ruleset. And the rule set is really just a collection of pointers to rules. And then in the assert of the test script, you reference either a rule for one or a rule set for a collection. Okay? Yes?
Can you reference a rule from another rule?
Well, a rule set can contain a rule.
No, I know.
I know, but no, a rule stands alone. Yes. So if I needed to have logic that might be used, like I have logic here which might fit into another rule, I generally will think in terms more of 2 separate rules and a rule set to collect them. Because the rule set can be executed as one assert in the test script. From a reporting perspective, if obviously if I have multiple rules in a rule set with one assert, the display in Touchstone will break that down into individual line items, one for each rule. So you know exactly which rule passed or failed within the rule set. Okay. And again, we can see some examples of that. So most of the rules and rule set work is being done in the hands-on exercises that if you want to come by my table, we can go through those in more detail. I can show you some examples here in this presentation, but I'll save the more detailed, complex descriptions if you want to come join me at my table. So let's move on to another topic here. One of the aspects of testing is a lot of times you just think about testing a server. And Touchstone, by default, acts as the client in the operation. So the test script defines an operation, like a read or a search or a create, and Touchstone will execute that according to the definition of the test script. And that's important because Touchstone as a FHIR client does not necessarily mean it's a FHIR conformant client. Touchstone acts as a client to execute whatever you define in the test script. So you can build a bad request in your test script because that's what you want to test. You want to test your server to see how well it reacts to a bad request. So that's called negative testing, which we highly recommend. But another aspect of Touchstone is how do you test a client? So Touchstone has built into it the concept of a proxy. So we'll be a man in the middle. So if you execute a test script where you have an external client defined, then Touchstone simply waits and listens for inbound traffic of that request coming from that client. And then it redirects it through the proxy to the destination server and then captures the response on the way out. So this way we can actually test both request and response, client and server, in one test script. Touchstone itself can act as another actor in the test script itself. So you'll notice we have different ways of dealing with server only, client, which is kind of your peer-to-peer, but also multi-actor. So the test script itself defines multiple actors that can act as clients or servers in the exchange of information here. Touchstone will always act as a client. It can't act as a server. It's not a FHIR server. So you may run peer-to-peer testing, and then you may want Touchstone to just do a read operation under the covers to go grab something that was created, and you could verify that. So you can build up some very nice, interesting, complex workflows just within a single test script with multiple actors. As an example of how you set that up, the test script is defined with what we call origins and destinations. So there's some elements within the test script that define this. If you don't define origin and destination, Touchstone or the FHIR test engine assumes one destination, a server. Okay? So Touchstone will prompt you always for at least one server, but if you define origin in there, it'll actually prompt you for an origin system, meaning a client system. In Touchstone, you define test systems as either being a FHIR client or a FHIR server. So that's why the list will be different here based on what type or what profile or actor of the system you're trying to use. So this will magically appear in the UI, and you'll be able to choose who your client is, and then the server, of course. This is just showing another thing that might show up. The test script itself defines things called variables. And variables typically are pieces of data that come from other resources, like the payload of a request response, or a static fixture, if you will, data that we're going to use subsequently in some operation. But a lot of times we may come up with a way to dynamically query or prompt for that data. Because this way, every time I run the test, I can put in different data. And I expect, hopefully, different results from that. So I don't have to tie myself to hard-coded data necessarily for the test. I can do what's called dynamic variables. Okay. And if you do that, they'll show up here, and you'll get prompted for that data. When you go to run this test script now, when you're doing peer-to-peer, normally what would happen is it starts running. Right? So there's a running status, and as you refresh the page, you may see things go to a pass or a fail, depending on the test step and what's going on. Well, for a peer-to-peer or a client test, we have to wait. And so instead of running, it now goes into this waiting for request status. So Touchstone is just sitting there. It's got a thread allocated to listen for that client to send the appropriate operation that I expect. And it'll sit there until you actually do something. Okay? Yes? Maybe. Depends on your asserts. Yeah.
But if the client passes and server fails, it will return the status as failed. But
Correct.
It will check that client is actually passed.
So, and we'll see that. So basically, you can drill down into the results. So this is at the high level. So this is at the test setup execution, right, where I have one test script. So if I click on that test script over there, I drill down into the test script execution definition. And here I've expanded the patient search operation that is being tested. Now, one of the things that we show you here, so notice we're still waiting for the request to be received by the client. One of the things we show you is, well, what are we expecting to receive? What are we listening for? Well, over here, this blue box is where we define exactly what we expect to hear or receive from the client. So we're expecting a GET, HTTP GET operation. The URL is now the Touchstone proxy URL for the server. So we take the server's base URL, and we're going to replace that with the proxy URL from Touchstone. Now, Touchstone has that mapping, so when it receives it, it'll just forward it on to the server, to the actual server's base URL. But that's what we expect. And then there's some other headers that we might expect too, like we're expecting it in JSON format, so the accept will be application/FHIR plus JSON. The user key and so forth, don't worry, I'll explain that in a minute, okay? But that's what we're waiting for. That's what we're listening for. Now, before I get to an actual live demo of showing you this in action, one of the aspects of peer-to-peer testing is you may go to your client and you may send that request, and Touchstone is still sitting in waiting for request because something didn't match. We're trying to make that match between the client system and what we're expecting. And you sent it, you know you hit something on your client, but it didn't show up as registered in Touchstone. Well, as long as you're sending it to that proxy URL, Touchstone is going to record the inbound request. It's whether we matched it to a waiting test execution. And so there's some logic here that we're going to run through to make sure that the client inbound request was mapped appropriately to the waiting test execution. So if your test server is already defined and it's publicly accessible, then the match is done by originating IP address. So your client has to be publicly routable. So we have an IP address assigned to your client. So we're going to try that first. Okay? So inbound IP address matches IP of known client. Okay? If that's not possible, then we have another mechanism called user key and org key. So you as a user, and for you who belong to an organization, we've given you these generated random strings that you can use in this peer-to-peer testing. So if you define an HTTP custom header called user_key, and you send your user key value in it, we can match by that. Because think about sitting at a Connectathon or a DevDays event, and you've got a client on your laptop, and you're sitting on the DevDays Wi-Fi for this building. What's your IP address? Good question. So sometimes we just don't know what your IP address is. So if you can leverage the user key or org key in your request from your client, and it doesn't have to be an HTTP header, by the way. If it's in the payload, you can do user key equals somewhere in the payload as a comment or in the narrative text or whatever. So we'll try to pull it out of that as well, too. Remember, we're in a testing environment, so we're assuming you can get away with some tweaks here and there for testing purposes. So if we can't match, then, well, what happens? We still record it. And so there's a screen in Touchstone for the captured message exchanges. So if we did make a match, you'll see that we actually have it correlated to a test execution, and we can see what the status is. But if we didn't make that correlation, this would be empty, and we would be, just a recording of the inbound request. Okay, so you can still look at that information, right? But and then you can determine, well, okay, the inbound request looked like this. The test was expecting that. There's the problem, right? So you can do some comparison work there. Does that make sense? Okay. So user key and org key are what we call placeholders within Touchstone for your user account. So when you go to your user account information within Touchstone, we have a display here for your placeholders where that's the generated user key, that's the generated org key. We have other placeholders which I can get into at the hands-on table, but for right now, this is what we're focusing on. And notice it's just a random string, and we guarantee that this will be unique for you as a user. That'll be unique for your organization. If for whatever reason you want to regenerate it, just click the regen button, and we'll generate a new string for you. You'll have to update your client to send that appropriately, but if you want to do that, you can. Another aspect that we have in Touchstone is the use of an API. So test executions generally are executed through the user interface, through the web interface. And so you've seen some of those screens already. One thing that you can do, especially if you have something like a continuous integration build server for your FHIR system, you may want to introduce testing from Touchstone into your build process. So we have built an API to allow you to do that. So the idea here is that, and we have documentation here for looking up this information, but the idea is that it allows you to do the same non-administrative functions, the test execution, remotely through this RESTful API as you would do through the user interface. So anything you launch remotely, if you go into the UI, you'll see it running. So the same interface will allow you to see what you've launched. The API services that are available is an authenticate process where we're going to give you a session key, and then that session key is going to be what you use in all the other API calls. And so you can execute or launch a new test execution from an existing test setup. You can get the results or the status of the known test execution at the high level, at the individual test script level, and so on. And then there's a test report resource type within FHIR that was introduced a little while ago. It still needs some work, but at least we support it right now through the API. So if you want your test script execution details in a FHIR compliant test report format, we can give it to you as well. Now, I do have an example of how I've done this internally. I have a Jenkins CI server, and I use that to build my Wildfire server. This is in my QA internal environment. And so I have a QA version of Touchstone internally within my Aegis infrastructure. And so I've integrated my CI build to my QA Touchstone environment. And then basically, I've documented how I did it in our online documentation. So if you go to our docs, it's all HTML-based now. So click on Continuous Integration API, and then right below that, you'll see the Jenkins example. So I actually used the Groovy plugin for Jenkins and wrote the Groovy script coding to do the HTTP request for the RESTful calls. And just what I do is I launch the test, and then I just do a 10-second delay, and I check the status. And I keep doing that until the status is complete, and then I can go grab the final results. And if everything is a pass, my build passes. If it fails, I actually fail the build, and then I can have a permalink to Touchstone into the test results. And because I don't have that publicly available, I can't demo that here, but it is fully documented within our online documentation. So other things that we do, conformance testing. So basically, that's exactly why we built Touchstone, is to allow for conformance testing of FHIR systems according to the FHIR specification. What we're trying to promote here with this environment is a continuous testing type of environment. We want to encourage you and help you with a continuous testing paradigm for your development efforts. So this is the marketing thing here, so, you know. Yes?
So your new slide, you said that you do verify the performance testing against the required elements.
Yes.
But how about the element value sets with the binding which are required, for example?
That's part of the validation. Yeah, so,
Some other status value, we can say that.
right, so the validation engine takes care of all of that. So the value set binding is defined in the FHIR profiles or structure definitions, which is what is used by the validation engine.
So do you, like, we have the binding required extension, for example?
Yes.
So if it's extensible, it will allow or provide a warning?
Yes, it will.
Pass the test case?
Yep. Mm-hmm. Yep. So yeah, if an assert were to come back with a warning, like the validation engine might report a warning, we'll still let it pass. Okay, the warning is not a failure.
Right.
Yeah.
But so do we have to add the assert for that or no? Like,
You still have to write, so there's an assert where you actually give a validate against a profile. So you write an assert using a call to the validation engine.
but I don't need to specify the value sets in there.
No, that's all defined within the structure definitions, within the profiles. Yeah. Mm-hmm. Yes.
Use, so if the profile has reference to an external terminology service, do you use that terminology service
Yes.
as validation, or is it?
So the way the FHIR validation engine has been architected, when the spec is built, all the value sets for FHIR are generated for all the code values for FHIR itself. Now some of those are like external terminologies like SNOMED and LOINC and so forth. So the idea there is if you need to validate one of those external code systems outside of FHIR, then the FHIR validation engine actually, you have to define what your terminology server is for the FHIR validation engine. So I actually use Graham's server as the terminology server because he supports SNOMED, LOINC, RX norm. He's got that all integrated. So I've downloaded Graham's FHIR server. It's open source. And I've built a VM in my cloud environment that hosts his server as my validation server. I do that because I don't trust that his server is always going to be up and running.
I was going to say, what's the performance hit on like validating for SNOMED?
Well, normally it's a simple lookup, so it's not too bad. I know. But yeah, so we're in a testing environment, so performance, we try to be as performant as possible, but when that external call goes out from the validation engine to the terminology server, there is going to be a bit of a hit. So we actually give you the timings of how long it takes for the assert to execute, and you can actually see when I call the validation engine, it's a little bit longer than what other simple asserts might be. If I actually have FHIRPath expression evaluations, you'll see that they take a little bit longer as well too, because I have to invoke the FHIRPath engine from the reference implementation, from the specification. And so that logic, again, you're running a query language processor, and so it has to evaluate the payload and go dive into things and so forth. So there is a little bit of a performance hit, but we've tried to, so we have an instance that's stood up, so the validation engine doesn't have to be instantiated every time. So I've got an instance running in a server. So we've tried to architect it so that we're being pretty good about our performance. Because eventually we do want to go do things like load testing and performance testing. We may not do validation engine calls when we do that because we're probably calling, we're trying to just load up against a particular server and see how it performs. But does that answer? Yeah, okay, yeah, good. Sure. Oh, sure, yeah. Right, so the validation engine uses it to validate according to the profile.
Not only if it is valid, also if it is valid for the value set required. Maybe you have only for a specific section, only these three codes LOINC are possible. Then you will which code are you using?
Right. And then for your particular use case, you may decide that, well, I'm expecting a very specific code out of the possible codes, and then you can do another assert to actually do a specific data value check in that regard, yeah. So one of the nice aspects about Touchstone is that it's an analytics engine, if you think about it. So we're retaining all of your test results, and we can actually show them in a nice, pretty dashboard here. So we have the sunbursts and so forth. So we group the test scripts into these test definition folders, if you will, and we can translate those into some nice, pretty pictures here for you to give you an overall representation of how well you're doing across those groups for that particular version of FHIR. So you'll notice here that my wildfire server is at 90%, but that's across all of the possible test scripts. I actually have one little failure showing up there as well, too. So there was a piece there that I didn't support that got run, and I failed that particular test. But now it's a good point. I didn't support that, but the test still got executed. So this is not necessarily an accurate representation of my conformance level. So there's a little checkbox up there called supported only in capability statement. If that's checked, I filter out any test scripts that I don't support based on my capability statement. So now I get a much more accurate result. So you notice that little red mark is now silver because I'm excluding it from my results. So that's just one of the features that we have. So you get a better representation now of how your conformance numbers are. And that takes us to an explanation of what the hands-on exercises are going to cover. So what I've done is I've uploaded into Touchstone. If you come by the hands-on desk, I'll show you where all this is. I've got test scripts that I've already written that you can start to run. And if you don't have a test server, you can use Wildfire. That's fine. I don't mind. It's publicly available. But we're going to be looking at that reliable, repeatable testing exercise. 2 users, same data. How do we, resolve data conflicts between 2 tests, if you will? Complex asserts with FHIRPath and XPath, JSONPath. Some examples of rules and rule sets. Advanced test scripts, peer-to-peer. And then I actually have I didn't know if you'd have time for something like this, but from scratch, if I take a test definition from like one of the last Connectathons that didn't have a test script, how do we write a test script based on the use case of that Connectathon track? So I've actually gone through that as an exercise as well. So I'm going to pause there. I have probably about 3 minutes to show you something. Hopefully I can do this in 3 minutes. But I wanted to, let me sign in. And just to show you where things live. So under test definitions, I've expanded, and you can see there's something called a FHIR sandbox there. The FHIR sandbox, and let me make it a little bit bigger here, is a folder where you can upload your own test scripts. So based on your subscription level to Touchstone, we give you the ability to upload your own. But obviously, I have rights to do so, so I've created a little Aegis folder under there for my organization, and you can see FHIR 301 DevDays 17, which was last November in Amsterdam, and then 18 for here. So yesterday's hands-on exercises are the intro, and today's are the advanced, the TDD2 advanced. And so just to show you where those things live. One of the things that you are probably going to be interested in is, well, if I want to take a look at rules and rule sets, so let me just click at this level here, just to kind of illustrate this. The test definition interface has some filters up here. So right now, we're only looking at just the test script resources. Okay? But if I wanted to look at everything under this folder structure, I could click on all, or I could actually just focus on rules and so forth. If I click on all, come on. There we go. So now I have a few more pages of things here. So things got reshifted a little bit here. But if I scroll down, I'll see if I have anything other than test scripts showing up right now. So here's some fixtures. So this is a fixture. Come on. Why are you taking so long? Okay. Well, let's see. Test script. All right, I'm not quite sure why it's doing that, but yeah, I don't know. It should be connected. Yeah, I've got connection. So I'm not quite sure why it's misbehaving, but let me focus on rules. All right. Yeah, it's connectivity is a little dicey right now, so it's taken a while to refresh. But essentially, Once this does refresh, we'll be able to see just the rules or rule sets that are defined under here. And I actually have some defined for my exercises for that as well, too. So, and if this...
So does Touchstone come with a predefined set of test cases?
Yeah, so under test definitions, you will find, let's see if I can, all of these folders that are already defined here. So you can see we're supporting from DSTU2, which internally was the 1.02 version. And then every time a Connectathon comes around, Graham does a snapshot release for the Connectathon. So we keep supporting all those intermediate releases. Yeah, I'm lost. Oh, well.
Validating profiles.
Yes.
Would that be something we would have to do custom, create test cases for that, or is something like that provided with it?
So, I'm sorry, say that one more time.
Say I wanted to validate that something, was Argonaut compliant.
Right, so basically, I have the Java reference implementation validation engine built into Touchstone. And by default, I load up all of the base specification profiles. I've now incorporated US Core, Argonaut. I've got the Australian base, the Australian provider directory, because I supported the last Australian Connectathon back in April. So they asked me to put their profiles in, so I said, okay, I can put those in. This is all for STU3 right now, by the way, the official release. I just got done loading up the IHE on FHIR profile for MHD, so the mobile health document. So those profiles are available. So you can write a test script now that supports the IHE on FHIR MHD profile. Here we go, we're back. And then run the validation engine with the known profile for MHD for, say, document reference or something, and I can validate that. But if you require anything beyond that, right now you need to contact us for me to load those up. I don't have an interface in Touchstone right now that will allow you to upload your own profiles. It's a feature request that we want to put in, but I just haven't had time to get there. So right now it's a manual process. Just let me know what profiles you would want and or need, and I can schedule to get those available. Yes?
One of the problems I've had when testing is that some of my systems are multi-language. So the message that I give to the developer when they fail should be in the language they use.
So,
I have a Portuguese, Spanish, and English version,
yes.
the same message. How do you manage that?
Right now we don't. So everything's in English. So basically, if you require,
I mean the assert.
yeah, the assert. Well, you could actually define the assert because it's UTF-8. It's a TestScript is a FHIR resource, and we're UTF-8 care set compliant. So if you want to write your assert and actually put the description in Spanish, you could. I know you need to be multilingual, so that's a different issue that we haven't addressed. So send me a request, and we'll put it on our backlog. We do Agile. I'm the Scrum Master. But yeah, so we can get that included as a feature request that we can prioritize and hopefully get in at some point.
I don't know if it's for Touchstone or for the assert per se.
Well, the whole idea with multi-language support is that you need to have whatever strings represent, the description and so forth, they're going to be in a separate location. So I'm going to have my Spanish strings, I'm going to have my English strings, I could have Dutch, I could have, whatever they might be. So I have all my keys matching up to those descriptions, and then we would need to be able to put the keys in to the asserts, right? Something like that. So we would have to go through and figure out logistically, programmatically, logically, how that all would work out. So, but yeah, we don't have that support currently, but that's obviously something that would be very important.
To me, the last Connectathon, we were testing our servers, and some of our tests are just error conditions.
Yeah.
We gave the developers the error condition in Spanish, and they say, what is it?
Yeah. What does this mean? Yeah. Yeah, exactly.
So we need to calculate that.
Yeah, so that we should probably talk a little bit more, and hopefully, we can figure something out. But yeah, that'd be good. Anyway, thank you.